Good evening. It's good to see so many people here tonight. I'm sure people are very interested in the program that we have for this evening, looking at the experts that we have speaking tonight, both local and otherwise. My name is Fred Lightfoot. I'm co-chair of the Canandaigua Lake Watershed Council, as well as being supervisor at the town of Gorham. About 6.5 miles of the eastern shoreline of Canandaigua Lake is in the town of Gorham. Therefore, it's quite important to me that we keep looking harder and harder at some of the possible ways that we can address this issue with the algal blooms and everything that goes along with it. We can assure you, the group of people who are on the council, the Watershed Commission too, as well as those are in the Watershed Association, have really been working very hard, as well as others, Department of Health and whatever other organizations may be involved. There's people that are taking this issue very seriously. We're working diligently to try and get our heads around this thing and see what can be done to minimize the impact to not just the residents of the lakeshore or the drinking water, but also anyone who cares to utilize the lake. It certainly is a dire concern. I wish that I'd never heard the words, cyanobacteria or microcystis, but unfortunately, like so many of you who would just as soon not have to deal with it, we all do. By all, I mean, we've all got a stake in a game. Doesn't matter where you are, whether you're lakeside, whether you're out in the country, even beyond the watershed itself. I think at this time I will be introducing Neil Atkins, who is the president of the Canandaigua Lake Watershed Association. It's only been a few months, isn't it, Neil, that you've been president? You people have done a good job. He's more than capable of continuing on. He and his wife Maggie turned traitor on me and moved to Canandaigua out of Gorham here a couple of years back, and it's been quite a loss to us. Maggie actually was a supervisor a while back. Neil has been extremely involved in many different aspects of municipal work. So anyway, Neil, it's your turn.
Canandaigua Lake Watershed Association is a 1,000-member nonprofit organization whose purpose is to protect water quality and overall environment of the Canandaigua Lake watershed for future generations by applying scientific research, advocating sound public policy, offering educational programs to the community. This summer, Canandaigua Lake experienced an unprecedented harmful algae bloom event that impacted our use and enjoyment of the lake for the first time ever. Detectable levels of toxins were found in the drinking water supply of the community drawing water from Canandaigua Lake. The Canandaigua Lake Watershed Association, along with its partners, Canandaigua Lake Watershed Council, Finger Lakes Institute, and New York State DEC, had implemented our 2018 expanded volunteer shoreline monitoring program at the end of July, with the goals to work with our partners to provide timely HABs information to CLWA members and users of Canandaigua Lake water. The collection of data under DEC protocol that will contribute toward the ongoing research of HABs across the Finger Lakes region and contribute toward potential solutions. We had 17 volunteers monitoring 18 shoreline zones around the lake. We had weekly surveillance for a 10-week time period. Our volunteers were trained to identify blooms and collect water sample using DEC protocol. Our CLWA office was used as a drop-off point for the samples that were taken. And we had a partnership with Finger Lakes Institute to analyze samples using our fluoroprobe. The information collected helps us to assess lake-wide conditions and aids in our public notifications.
I'm sorry.
That's okay. We had 155 weekly shoreline surveys performed, 54 water samples collected by volunteers and Watershed staff and submitted for lab analysis. We had 25 DEC confirmed blooms and 23 confirmed with high toxins. If you want to get involved, become a CLWA member. Sign up to volunteer and forward our email blasts to neighbors and friends to help us spread the word. Lindsay McMillan, our association director, will introduce tonight's presenters. Lindsay?
Thank you, Neil. Kevin, why don't you come up here? First, I'm going to introduce Kevin Mulvaney. Yep. Why don't you go and do that? Kevin Mulvaney is the Watershed Program Manager for the Canandaigua Lake Watershed Council. The Watershed Council consists of publicly elected officials in all 14 municipalities within the 174 square foot mile of the Canandaigua Lake watershed. Kevin has worked for the Watershed Council since 1998, coordinating the implementation of the Comprehensive Watershed Management Program. Kevin received a master's degree in water resource management from SUNY ESF and an MBA from Syracuse University, along with a bachelor's degree in political science from Siena College. He's been an adjunct instructor at Finger Lakes Community College since 2001, teaching classes in water and land resource law and environmental planning. Kevin's a very active partner with the Canandaigua Lake Watershed Council, and we look forward to what he has to say. So thanks, Kevin.
Thanks, Lindsay.
Hopefully this works for you.
Fair enough. Yeah, I think I'll stay here. It doesn't seem like this the remote control is working well, so we'll kind of have to stay stationary, it looks like. I have 10 minutes, so my goal is to get through this thing pretty quick, but to give you a lot of information as to what has occurred over the last few years in terms of the blue-green algae blooms that we've been dealing with in Canandaigua Lake. And then we have 3 experts at the state level that are going to give us a lot of the macro level, what's going on statewide, and then also what are they really seeing in Canandaigua Lake as well. So we look forward to that. I've got Lindsay up here as a co-presenter, so as we go through this, there may be questions later on that we can both be able to answer. This partnership that we have is critical. We have the Watershed Council, the Association, the Watershed Commission that all have been mentioned. So they play critical roles, and we really, really try to complement each other to make sure it's not the silo effect of, well, we're doing this, you're doing that. We work together, and that, I think, is critical. We're on the governmental side. I have 14 bosses. Fred is one of my bosses, and we're somewhat unique around New York State where we have all the municipalities working together, and we want to make sure we coordinate with the association. Just some basic facts about the lake and about the watershed area as well. Lake is 15 miles plus long, a little over a mile wide on average, about 10,500 acres roughly of lake surface area. Some other key features: 13.4 years it takes a drop of water from the south end of the lake to make its way through the lake and into to the outlet. That is a critical feature because it's what that water is bringing with it from the drainage area, that surrounding drainage area. The land uses in that area is coming with that water. So it's not like a river system where it goes right downstream. That pollution that comes into the lake has an impact for a long duration of time. Some other key features is how we benefit, if you will, from the lake as well, or in terms of resource base. One, we use it at lake as a water supply for 70,000 people. We know about what happened in Rushville, and that is a very scary thing when we think about not maybe 1,000 people, but now up to 70,000 people from a lake perspective, possibly losing this as a water supply. So this becomes very serious when we start thinking about those components. The other aspect is we are a mini Eastview Mall. Our assessed value is $11,000 per foot of shoreline. You start in many areas. You start thinking about that tax base, and the rate reductions that that causes for the overall municipalities, that plays another key role. So in 2015, we had our first Lake HABs event. It was a substantial event. It was something we had not recorded before, experienced before. Dr. Bruce Gilman has been on this lake for a long time. Many others from a lake perspective as well, looking at this. Really our first recorded lake event in terms of the HABs that we were seeing out there. So that was something new to us. I remember going to some presentations at Honeoye Lake and thinking, wow, what would happen if this happened really on Canandaigua Lake? But we're such a low nutrient lake, and we still continue to be a low nutrient lake. So that really is causing some major questions as to why we're seeing it on Canandaigua Lake. So 2015, a brief history, pretty substantial event. Northern 2/3 of the lake, so top 10 miles of the lake, really experienced blooms. We were seeing it shoreline and mid-lake, but nowhere near the peaks that we were seeing in 2018, and nowhere near the geographic extent. We had a full lake-wide bloom. 2016, major drought year. We did not see the blooms really except for very small isolated locations. And this is really our 4th year of a volunteer program. This year, thankfully, we had a much more formal, structured program to utilize the volunteers. But we had people in 15 calling us from all over the place. 16, we also had some folks. 2017, again, we actually had in late August a cool, wet period because we were starting to see the bloom really starting to take shape and take form. And then we had a very cool, wet 2 to 3 week period that knocked it down, but then we had in the second half of September, blooms occur because those temperatures went back up and the sun was out there. And then 2018, we saw, and you'll see the pictures of what happened and ultimately the impacts from a toxic perspective on the village of Rushville's water supply. So here's some of the photos. I really want to kind of fly through some of this, but the vibrancy, we did not see this before in 2015, which was our most substantial event before 2018. So here's some other pictures. At September 4th, it was the day after Labor Day. I remember going around, Lindsay and I were talking, and all of a sudden it was, by 7:30, 8 o'clock in the morning, it was intense. And the volunteers played a huge role in getting these pictures, getting samples, partnering with FLI to get a lot of these results screened, and then ultimately to DEC. Here's some additional pictures where you can really just see, that 2015 picture that we have does not even compare to what we were seeing on September 4th. And it continued. Out in the middle of the lake, I remember being out at my boat on the middle of the lake and just looking at some of these areas that were just intense. And we had one of the local pilots was flying, and I had sent an email to the folks that fly out of the airport saying, hey, if you're up and you see blooms, please take pictures. So Turnbull took a picture of some of the areas, and you can really see those blooms from an aerial perspective. So again, here's some more pictures of kind of what it looked like just south of German Brothers Marina. Again, just the extent. I think on that September 4th time frame, there was at least 11 miles of that western shoreline that looked exactly like that. So what's causing this? And we have some experts here, and I have to fly through this because we're a little bit behind schedule. So I'll talk through each of these with some slides. But since 2015, and looking back 2012, 2013, what has changed in the watershed that might be triggering this? Our phosphorus levels aren't going up, and that's the limiting nutrient that really does drive algal growth. So what has changed in the watershed to trigger this? We have some clues. We'll talk about some of those tonight, but it's really going to require a lot more research, a lot more partnering with our state folks. One of the things we know that has happened over the last 6-7 years, we are seeing on a more frequent basis these extreme rain events, and that matters for multiple reasons. It's bringing in, from the biggest thing is it's bringing in a lot more polluted runoff into our lake area. We know in 2011 we had FEMA level events that were just bringing huge amounts of damage and impacts. We know there's studies out there that are showing we're seeing extreme storms becoming more than normal. But for 2018, we didn't have an extreme storm event anywhere in the watershed. We didn't have one of those heavy runoff events. Pretty dry summer, quite honestly. October was horrible, but when you look at all the way through that season, the streams went dry. What triggered this? So it's not just the extreme rain events. We know it's more complex than that in terms of the pollution that's occurring. Here's a quick video. Let's see if it works on this machine. But this shows you what one of those extreme rain events looks like. This is a 300-acre subwatershed, very small drainage area. That is a road where that water is cruising down, and then you have a full stream off of that that's also moving. So we know that that is an important part of that. That's a very small, when you have 109,000 acres of drainage area, that's 300 acres coming in. Think about what's going on elsewhere in the overall subwatershed, and overall watershed basin. So that is bringing a huge sediment load, a huge nutrient load with that has that impact. Dr. Gilman, over the last 20 plus years, is documenting warmer summer lake surface temperatures, and algae love warm water. So we're seeing that, and it's that subtle increase, and it could be a combination of subtle increases that magnify and really impact the ultimate component. We're seeing articles in the paper about agriculture, DNC article about issues in Canandaigua Lake. We have about a third of our watershed areas in active agriculture, less than Canandaigua Lake and some Owasco Lake and some of the other lakes that are out there. One of the articles really emphasized the aspect of CAFO farms, factory farms is what they were calling them. We don't have factory farms really in the region, quite honestly, for the most part. We have no CAFO farms in the watershed. We do have 4 family-run CAFO operations that are in close proximity to the watershed that do spread manure in the watershed. So this is one of those things that's being asked about, talked about, and it's an important thing that we have to look at. That manure application is a huge potential source of nutrients, but it's also a huge resource for the farmer. So it's that balance aspect that we have to look at, and we also have to think about the extreme storms. Some of these pictures are moderate level storms, what you saw. It's that combination of how do we build watershed resiliency into the overall component. The other thing that's being looked at in the Lake Erie Basin is the use of Roundup-ready crops and the increased use of Roundup-ready crops. And that's one of the things we're exploring, looking at, a lot of research out in Lake Erie area of when glyphosate, which is the active ingredient, as that breaks down, there is a phosphorus component to that blue-green algae may be able to utilize. Now glyphosate, the active ingredient in Roundup, has been used across the country for 50 years. Maybe we're changing how it's being used, so that's another aspect that's being looked at as a component as we look at what is changing, and that's a gradual change that may be occurring over time. We're not seeing more land really being farmed in the watershed, maybe some changing practices here and there, but the other thing we have to remember, we've had millions of dollars where we've had tangible success through our soil and water conservation districts, NRCS, and local farmer share, where a lot of really good projects have been put in over the last decade and a half. So, and a lot of those things need to continue, especially with these extreme storms. So the other thing that's changed over the last decade is development. Across the Finger Lakes region, not much development going on. In our neck of the woods, some development in our watershed, mainly that middle Cheshire corridor of the town of Canandaigua. So we've had some growth going on in that area that's been occurring. The town of Canandaigua, where a lot of that development's been occurring, has had enhanced phosphorus treatment regulations in place, full-time code enforcement officer, great plan review structure in place. We've had issues, but they've been rectified. We've been working with those developers, and we have long-term success, I would say, in terms of the treatment of the water coming off of those developed sites. We have individual lot development, still a net impact for sure, but we also have a lot of regulations and more regulations, I think, coming down the line on the individual lots, on what's going on along the shoreline, and those kind of issues. Another aspect, and I've stole a couple pictures from Tony, so he's going to reuse these, and I apologize, Tony, but they're so good. I had to use them. These are pictures of the lake bottom. This is one of those other things that Dr. Bruce Gilman and others have identified back around 2010, 2011 time frame, somewhere in that time frame. Quagga mussels came into Canandaigua Lake, and they're basically the bigger, badder brother of the zebra mussel. They do everything better than zebra mussels and have outcompeted zebra mussels to the tune of about 85–90% of the biomass, mussel biomass is quagga mussels. And why does that matter? Because they do everything better, and they actually create almost at the late season a monopoly for blue-green algae to take off. because they're filtering out all the good algae. They regurgitate the bad algae, the microcystis and the blue-green algae. They don't like the taste of them. And they actually put out dissolved phosphorus. So they're doing everything incredibly efficiently, and are they the trigger that might be changing the ecosystem in the lake that is now making our lake much more sensitive to subtle increases in phosphorus and what's coming in from the watershed bases? So those are things that we're looking at. We're seeing algal abundance with Dr. Bruce Gilman and now Patty's research in the lake increasing potentially over time, and primarily dominated by microcystis late season. So what can we do about it? And again, I got to fly through these, is build resiliency into the watershed. Slow the water down and create water quality projects throughout the overall basin to try to have these kind of impacts. And we're doing a series of these projects. This is in the Sucker Brook subwatershed, which has the highest phosphorus concentrations going into the lake. We have our watershed management plan that goes into a lot more detail. We have another project that was just put in where we put in a weir structure in a stream on Sucker Brook actually to convey the water out of Sucker Brook and bring it out into over in here, a 17-acre natural basin that we did very, very little construction in to filter that water naturally. The south end of the lake, we're looking to do a very similar thing where 50% of the drainage area ultimately comes into the lake. We're looking to build these types of resiliency projects to reduce the levels of phosphorus, nutrients, and other contaminants going into the lake. There's some close-up shots of an area that the Nature Conservancy bought that we're working on a 200-plus acre project that's pretty complex in terms of different aspects. Fallbrook, which drains into the north end, also another project that we're looking to put in. We've got grant funding to build more resiliency into the watershed, to reduce these sediment plumes that are carrying more than just sediment into the lake, and to build a 17-acre basin in that area. So, you know, we started looking at these components before the blue-green algae blooms. They took higher priority because of these issues. And we start to ask ourselves, 20, 30 years from now, is this truly going to be the new normal where we're just going to have blue-green algae blooms, not just in late August and September, but maybe early August? What's going to happen to this lake in the long-term component that really is going to raise a lot of these major issues from a water supply perspective or a recreation perspective? So we need to build that resiliency into the watershed. And it's not going to be the Watershed Council. It's not going to just be the Watershed Association, just DEC, DOH being able to take this on. We all have to work together. So I thank you, and I think I went over my time, but hopefully we can now move on with the state folks.
Come on up, Rebecca. Thank you very much. Our next presenter is Rebecca Gorney. Rebecca Gorney is a research scientist with the New York State Department of Environmental Conservation, Division of Water, and manages the state's Harmful Algae Bloom program. She also participates in the state's 2 core lake monitoring and assessment programs. Rebecca has been with the department since 2015. She received her PhD in natural resource management from the University of Vermont. Her recent work includes expanding the state's HABs program to include enhanced volunteer surveillance programs on several Finger Lakes, development of a comprehensive database for management of the state's lakes data set, and contributions to the agency's efforts to expand research and outreach efforts on the topic of HABs. We welcome you. Thank you.
Thank you. Thank you everyone for coming, and thank you to the Canandaigua community for being an excellent partner. As Kevin's mentioned, we've been working together for several years to address issues related to harmful algal blooms on your lake and potentially more in the future. So just a refresher on what we're talking about today. This acronym HABs originally comes from the marine world, so you may have heard of red tides and other algal blooms that occur in ocean contexts. And there's a slight difference in lakes and freshwater. We're talking about cyanobacteria, which technically are not algae, but they act very similar to algae. And the term blooms is also kind of a tricky term because we don't have a great definition either internationally or nationally. There's no hard term of what is a bloom or what is the risk related to a bloom, but there's a big visual component. So everyone can look at that photo and agree that's a bloom. So that's a very dense concentration of cells, And in some aspects, the state relies very heavily on that visual component, for example, for beach closures, which are triggered exclusively on visual sight. And that's why the volunteer monitoring is extremely helpful, because they're able to go out and see and report bloom occurrence very easily. But of course, testing is valuable as well. So the New York approach to, sorry, the slideshow is not showing the presenter view, so pardon me for 1 second. All right, well, we'll make do. So, the efforts related to harmful algal blooms on a statewide effort level are very collaborative. The DEC and the Department of Health, both on a statewide level and local level, work together extremely closely. We communicate regularly, and our goals are the same: to protect human health, to protect recreational use, drinking water use, all of the functions that our lakes serve. And there's a lot of different parties involved with these efforts. Sorry, this is not working for me. Maybe I can do that. I don't know why it's not showing the presenter view on this view. It's showing correctly on the screen, but not on the computer. So I guess I could just turn and look at the screen. We'll do that. Okay, sorry about that. So, again, we're interested in protecting human health, and both the DEC and the Department of Health agree this is a problem that seems to be occurring more and more throughout the state. There are a lot of different parties involved, from the bloom detection aspect, which is, of course, the DEC and the Department of Health, but also addressing the causes, where we work with the Department of Agriculture and Markets and Soil and Water Conservation Districts. I know it's a lot of acronyms. That's government for you. We work with a lot of NGOs, for example, the Finger Lakes Institute, and experts from academic institutions. The issue that we're concerned about with regard to health are several different types of toxins that can be produced by HABs. The most common in New York State is microcystin, and that's the only toxin for which we have public health advisory levels for both recreational context and drinking water context. However, blooms can create other compounds, for example, anatoxins, which are pose particular health risks for dogs because they can consume a large quantity when they get algal material concentrated in their fur. And then in addition, there are dermal toxins known as lipopolysaccharides, which are present in pretty much all HABs, whether or not the other toxins are present. So those dermal irritants, which can cause skin rashes, etc., are part of the reason why the state suggests avoiding all algal blooms, whether or not toxins are known to be present. There are several different known causes for harmful algal blooms. As Kevin has already mentioned, we know phosphorus plays a huge role, but there are some wild cards. Again, Kevin has touched on all of these already, and we are in the process of conducting research, and the scientific community at large is putting their heads together about how these factors interact with harmful algal blooms. This is not a problem that's unique to New York. These blooms are occurring all over the planet, in every continent, and most of the types of cyanobacteria that are present are the same in other parts of the world. So this is an issue that's impacting a lot of the planet. In the US, the EPA evaluated, okay, where are states reporting harmful algal blooms? This map is from 2016 and reports the numbers by EPA region. Those are groups of states. And look who's number one. Does that mean that we have more blooms than any other EPA region? Not necessarily. Does it mean that we are doing the best by far in reporting them, letting the public know, getting word out there? Yes, that's what that means. So New York is a real leader in this effort, and we intend to stay that way. The DEC in particular relies on a network of samplers and surveillance efforts. So most of the harmful algal blooms that the DEC reports were reported to us by our networks. There's a citizen science program that evaluates lake water quality called CSLAP that's conducted on over 150 lakes annually by lakeshore residents, lake association members, trained citizen scientists, similar to the enhanced volunteer efforts going on several Finger Lakes. We also have some state lake monitoring efforts, and we partner with groups such as the New York City Parks and Parks Department, which has several harmful algal blooms within New York City, Central Park in particular, Prospect Park. And DEC staff is also involved in this effort, and the Department of Health often reports to us beach closures, and the State Parks Department also reports beach closures to the DEC. So there's a lot of different parties bringing together information. And what the DEC, oh, sorry, this is more information about our sampling programs. I won't dwell on that for the purpose of time, but just know we're checking a lot of lakes every year. Here is even more information about all of the lakes that we're checking every year. So it's roughly about 400 lakes that are being evaluated on either a daily, weekly, or annual basis for harmful algal blooms through this very complex network. When a sample is collected, we measure it for three main components. The first is chlorophyll, and this is kind of a surrogate measure for how much algae is in there. There are a lot of different ways you can measure algae. This is one that's pretty effective. This device on the right, the fluoroprobe, is what is used at both the Finger Lakes Institute and the Upstate Freshwater Institute, and that is able to scan the samples very quickly and give you a measure, not just of the chlorophyll, but the chlorophyll created by the cyanobacteria. So we call that blue-green chlorophyll. And then the samples are evaluated under a microscope, so looking and seeing what type of phytoplankton, other types of algae, or what types of cyanobacteria are present in the sample. And then the samples are also evaluated for toxins, in particular microcystin is the toxin that we are most commonly detecting. So all of that information from our network of samplers and our lab results and beach closures is all evaluated by DEC, and we apply bloom status, which I'll go into more in a moment. We do a lot of outreach related to educating folks about harmful algal blooms, doing presentations such as this. Our website has a lot of helpful information. This bottom right image is the cover of a 40 or 50-page program guide, which summarizes pretty much everything I'm telling you about tonight. I have some copies here if anybody wants one to take home. I also have printed lists of all the bloom locations in the state, and you may have received our brochure on your way in, so a lot of outreach efforts. But the main bulk of our outreach is those bottom two bullet points, daily notification emails that we send out to regional DEC staff, local health departments, state health department, and other sampler groups such as lake associations to let them know when, where blooms were reported. If there's sampling information, we share that with them. We have a system to blast those out almost daily. And then our weekly update to our website, which has a map of all of the bloom locations in the state, is heavily used by the public. And if you're not already familiar with it, it's down for the winter, but it'll be back next May. And that is more interpretive information. We don't post the raw data there. We post the bloom status, the size of the bloom, and we just have one point of information per lake, which is why working with large lake groups like Canandaigua, where you can get more information about your lake, is helpful for your usage. So just quickly, how we evaluate the bloom status, we're first looking at who is telling us that there's a bloom. Is it somebody such as our volunteers or a beach operator who knows what a bloom looks like? If yes, then their bloom report is immediately determined to be what's called a suspicious bloom, which essentially means it's a credible report. We know it's a bloom, but we haven't been able to sample the bloom. If not, then we look at photos provided, evaluate the history of the water body, and then determine if it meets our criteria. If it is a suspicious bloom, we attempt to sample it. Not always possible, but if it is possible, then Here's what we're looking at, that blue-green chlorophyll that I mentioned, measured by the fluoroprobe. We have a threshold of 25 micrograms per liter of chlorophyll, and above that number, there's a higher likelihood of health effects, so we determine if there's that much chlorophyll, it's a confirmed bloom, also with microscope evaluation backing that up. Then we look at the toxin results, and if those are above those thresholds, then we determine it to be a confirmed with high toxins bloom. But it's important to mention that it doesn't matter which of these bloom levels that we're reporting out. The basic warning information, the educational information does not change. It remains avoid contact with the blooms. I also want to point out the order of magnitudes, plural, difference between these thresholds and those that Lloyd will talk about a little later regarding drinking water. This is more of a recreational health risk context, not directly tied to the drinking water. So yes, avoid all blooms. This is what our map looks like. Again, down for the winter. It'll be back next year. Here is a summary of the number of water bodies that have had blooms of each status over the years. And the map is a cumulative map of the location, so that's where we had seen blooms as of 2012, 2013, 2014, 2015, 2016, 2017. Unfortunately, I'm so sorry I don't have the brand new map, but spoiler, there's more. They're pretty much everywhere in the state. The Finger Lakes region certainly has a high density, and some of the downstate areas have an even higher density, but they have a lot more development and a lot more lakes. So it turns out when you look for harmful algal blooms, you find them. Here is just a graph with the cumulative number of water bodies that we've detected each year. It almost looks fake. I just put this together last week, and I had to second guess myself, but that does seem to be about correct. Each year we find between 50 and 70 new water bodies that never had documented HAB before added to the list. We're getting close to 400 now. And this is some information from the health department, whereas we're finding new locations every year. This is information from basically the same set of locations every year, 1,400 regulated swimming areas, beaches that are being evaluated in the same way every year, and the number of beach closures seems to rise there. 2018 is higher still than 2017. So now some news updates. Most of what I've told you has kind of been business as usual for the last few years. Earlier this year, right at the start of the season, the Department of Health implemented a ELAP protocol for microcystins, which means we have a standardized way of testing for microcystin, and several labs around the state are now certified to provide that data. We expanded our sampling in rivers and stream systems. We're looking to see if there are cyanotoxins in those systems, and if there are, then we should be monitoring those as well. And here's some summaries on the number of samples collected through the statewide lake monitoring programs that DEC oversees. And a little summary of where HABs are most common. Again, downstate Putnam County, that is the epicenter of beach closures, and there's, again, a lot of lakes, but a lot of lakes with HABs. In the last few years, the drinking water impacts and recreational impacts in the Finger Lakes have really kind of brought the HABs issue up in the statewide profile and nationally as well. The first detection of cyanotoxins in drinking water was on Owasco Lake in 2016, and quickly led to upgrades to their drinking water treatment operations. Skinny Atlas Lake has had detections in the last 2 years, not in the treated water, but in the raw water as it goes into the intake pipes. And last year we had HABs detected in all 11 Finger Lakes at some point throughout the summer. This year is just 10, not 11. And then, of course, the Do Not Drink advisory here earlier this month. But don't want to leave out the rest of the state. In 2016, we had a very widespread bloom in a river for the first time in New York. No New York history, it's occurred in other places, but the Wallkill River, a tributary to the Hudson, had a very dense bloom. This photo is from right in New Paltz. And Illness reporting is being tracked by the Department of Health, continue to find not a huge number, but a moderate number of cases annually. And this year in September, we had the highest single week of water bodies reported on our map at once, which was 98. The governor got involved about a year ago with some announcements of dedicating resources to this issue. So it's called the HABs Initiative. It was unveiled through his State of the State in December and January with 4 main aspects. They selected 12 priority water bodies to do some focused research on, and additionally some HABs summits, which were focused on those 12 water bodies and action plans. But also there is more widespread research efforts that are coming out of this initiative that have implications for the whole state. The 12 water bodies were spread throughout the state. They covered a swath of sizes, watershed uses. Most of them are drinking water supplies. Most of them are heavily impacted by HABs already. But for example, Lake George is also included because they don't have HABs. So maybe we should figure out what they're doing right and use that as a model in other places. And the 4 summits were focused on each of these regions. This all came together very quickly. Again, it was announced in December. We had the summits in February, March. The action plans were completed by June. It's been a roller coaster ride. The summits included portions that were open to the public, as well as invite-only sessions with invited experts and statewide experts and local stakeholders and members of the communities around each of these focused water bodies. And it was a really functional, good model of how to work together and bring everyone to the table. And we were able to invite several experts from national academic experts from around the country who work on this issue, and they were able to contribute substantively to the conversation and inform us about what we should be looking for, doing how we can expand our own efforts to research and manage HABs. Our take-home messages were really, it's not just phosphorus, we also need to pay attention to nitrogen. Conveniently, most loading that brings in phosphorus is also bringing in nitrogen, so management efforts to control those nutrients generally go together, and that the cyanobacteria are not that picky. Whether the phosphorus is coming from agriculture or urban runoff, they don't care. They will use it all the same. So we need to manage all sources. And that this is a complicated issue. There is not one silver bullet. There is not one quick cure. It took us a long time to get to this problem, so it's probably going to take a while to fix it. But we're working on it, and we are expanding our efforts in studying it. We have launched an advanced monitoring pilot on several Finger Lakes, which has implications for Canandaigua as well, as we better understand what happens when a HAB forms. So you can actually go online and see in real time water quality data from Owasco, Seneca, and Skaneateles lakes, and these will be expanded in their capabilities next year, including bloom cams, like webcams that are real time, where you can actually see the bloom and also see what the sensors are monitoring for chlorophyll, temperature, oxygen, et cetera. And we're doing some mitigation pilots. So these are the tools and strategies that can be used rather than looking at the nutrients coming in, but to actually treat the lake, treat the HABs in lake. So rather than starting with Finger Lakes for that, we're starting with much smaller water bodies around the state. We have a few that we're undergoing the process to test these different strategies. This is a subset of the partners that we work with. We are, again, extremely reliant on all of this collaboration and try not to operate in a box, but really work together and take input from all these different parties, and we are committed to expanding that in the future. So that's what I have, and Tony will be next, and I'm sure we'll have some time at the end for questions. Thank you.
Thank you, Rebecca. Our next presenter is Tony Prestigiacomo. Tony is a research scientist with the New York State DEC's Finger Lakes Watershed Hub. who has a background in water quality monitoring and assessment of lakes and streams in New York State. Tony's interests include water quality monitoring, watershed nutrient loading, and transport and fate of stream inputs to lakes and management of lake water quality. Welcome.
Thank you. Can everyone hear me okay? Okay, very good. Going third has its advantages. Luckily, Kevin stole a bunch of my slides and presented them already, so I can go much faster. And Rebecca did much more justice to the HAB slides than I can, so we'll get through my piece pretty quickly. So a quick little outline. Looking through, let's take a step back and talk about why phosphorus is bad. We've heard some things about nutrients. I'm going to do a little bit of a background. Usually in lakes like Canandaigua Lake, phosphorus is the limiting nutrient. So when you add more phosphorus, more nutrients, that tends to spur biological growth, including macrophytes, algae, and that can be problematic. Excess phosphorus can result in persistent algal blooms, which can result in ecosystem impacts, poor clarity, aesthetic degradation, and drinking water health effects. And so I'm going to start there and talk more about nutrients on the back end of this talk. Okay, so in the not so distant past, persistent HABs were usually common to higher nutrient lakes. Numerous studies, Downing 2001, Edmondson out in Lake Washington, Canandaigua Lake locally, other folks in the 1970s, all documented how if you allow a lake to become eutrophied through cultural activities, you can have, if you wouldn't mind, that would be great.
It's disabled.
That's okay, we'll make do. Okay, so a lot of those studies were in the 50s, 60s, 70s, but up until recently that was the case. And so a few quotes from Downing's review of harmful algal blooms in 2001. I'll quote, "The risk of cyanobacterial dominance is only between 0 and 10% between phosphorus levels of 0 and 30 micrograms per liter." Okay? Minimal risk, also a quote, of cyanobacterial dominance requires lake total phosphorus concentrations below 30 micrograms per liter parts per billion. Okay? And so recently, we're seeing harmful algal blooms on much, much lower nutrient lakes, which Rebecca and Kevin have both talked about. That's a picture of the Skinny Atlas Lake bloom from 2017. Those of you familiar with the yacht club, or the country club, that's one from Cuca Lake in 2018. And of course, we've seen pictures of blooms on Canandaigua Lake. And the problem with what we're experiencing lately is we're getting these blooms on lakes with total phosphorus concentrations well below 30. And I realize that the units on this are in milligrams per liter, not micrograms per liter. So the 0.03 milligrams per liter is equal to 30 micrograms per liter. That red line is that 30 cutoff from that Downing quote, okay? These are CSLAP, so Citizen Statewide Lake Assessment Program results from 2017 from all the Finger Lakes. And you can see that all of the lakes in 2017, with the exception of Honeoye, were well below that previous defined cutoff of 30 micrograms per liter. And yet, as we've heard, all of the Finger Lakes in 2017 had a harmful algal bloom of some description. Now, the sizes and extents differed, but they were all reported on the Finger Lakes. So this is a relatively new phenomenon for us. Okay. This is long-term Canandaigua Lake monitoring data. You're very lucky here to have such a long-term consistent record of water quality in your lake. This is from the Canandaigua Lake Watershed Council and Finger Lakes Community College. And you can see that over time, from the mid-90s, the phosphorus concentration in the open part of the lake has fluctuated a little bit here or there, but generally between 5 and 7 or so parts per billion. very low phosphorus numbers. Again, the summer average values from the Citizen Statewide Lake Assessment Program confirm those numbers collected by Bruce Gilman and Kevin over the years. Okay, Canandaigua Lake, despite its HABs, is still a low nutrient lake with relatively low open water chlorophyll and fairly high clarity. Okay, so why Canandaigua? Why now? Rebecca went into depth about the governor's HABs initiative. But some of the things that came out of those discussions with the state experts and the national experts was that there are some factors that are common to lakes that experience HABs. Okay? Temperature and precipitation patterns. Cyanobacteria tend to like warmer temperatures. Wind speed and direction, lake orientation, fetch, which is the distance at which a wind can act on a water body. All those things, New York State found statistical correlations between those lake variables and the reporting of HABs on those lakes. Also, dry-scented mussels, zebra mussels, quagga mussels, and then, of course, nutrients and the types of nutrients that enter our lakes all have an impact on harmful algal blooms. Okay, this is kind of a scary graph. The top one, does the pointer work? It does. Okay, so the top graph is July through September average temperature from 1900 through 2018 from Cornell University's long-term meteorological station in Ithaca, okay? And so the arrow, the long-term annual and summer trends are messy, right? There's a lot of variability year to year. It's different. And you can see the overall trend from 1900 through the present isn't very clear. The late summer trends, so this is the September average for each of these years. Similar, tends to be highly variable, but no clear trend when you look back the full 100 plus years. A quick reminder that all of these lakes generally undergo a fairly routine succession in algal growth in the summer, or in the season. The algal community tends to be dominated by diatoms earlier in the spring, tends to be dominated by green algae in the middle part of the summer, and then mid to late summer, cyanobacterial dominance in our lakes is not an uncommon thing. It's uncommon for it to be at bloom levels, where we see the pictures that we've seen so far tonight, but they are present in the water column and they can dominate at times. Okay, so these graphs, sorry, I'm craning my neck a little bit walking around. These graphs are the same graphs, but I've highlighted from 1990 to 2018 in orange, okay? And so if you look at those years alone, for July through September, you can see that we're on a fairly consistent upward trend in summer average temperature, at least at the Ithaca station, okay? And for September, you can see the same thing. From the 1990 to 2018 period, we're on a definite upward trend. All right, so climate change is impacting our water bodies. It was good to see, this is air temperature. It was good to see Kevin's description of water temperature because that's where the bacteria live. But this is really impacting our water bodies and contributing, I think, to HABs. If you look back in time on this graph, 2018, you don't get a warmer summer or September average temperature since the 1950s. So it's been 50 years since we've seen the type of temperatures that we've seen over the last few seasons in Canandaigua. Okay, and just for reference, 2015, the September average temperature was 18.4 degrees, which was the warmest on record since the 1960s. And 2018 was the second warmest on record in the past 50 years. Okay? So these things are impacting our water quality. I stole this graph from Kevin, actually. He didn't steal that one from me, but it's the same story, right? We're getting more rain. We're getting heavier rains. They're washing nutrients and pollutants into our lakes. This time series graph is the annual precipitation at that same Met station in Ithaca. So total precipitation by year is also increasing. You can see prior to about the 1930s, I think we had 1 year at that station of more than 40 inches. And if I counted right, since 1990, I think we've had 7 years of more than 40 inches of rain in a year. So again, another climate factor that is really degrading our resources. This is a paper from Steve Chapra and a bunch of other folks who talked about water quality modeling and trying to forecast for HABs. I'm going to step aside and let you read that really quickly. I'm kidding. I'm not going to make you read it, obviously. This should. Oop. I've highlighted the kind of take-home message. I'll send you the link. It's a great paper. But what they did was they linked global circulation models, climate forecasting models, fed those into nutrient runoff models, and then lake water quality models. People that are much smarter than I am, they pulled that off. And so what they found was that due to climate change, okay, cyanobacteria concentrations are likely to increase due to increases in temperature and increases in heavy runoff. Okay? And that the largest increases in cyanohab occurrences were going to be in the Northeast, consistent with warming trends and those heavy precipitation runs. So as we move forward with how to monitor, how to assess, how to mitigate some of these problems, we really have to keep our eye and look at where the climate's going to be and not where it is right now, because things are going to change. These projections were through 2050 and 2090. So this is a real problem that we need to keep our eye on with fixing our watershed problems. Okay, so dry-scented mussels. There are two types in Canandaigua Lake. The zebra mussel, which is this guy here, came in around 1994. The quagga mussel, which is this one here, came in around 2010. This past. So a lot of this work, kind of teasing out the relationship between mussels and HABs has been done in Michigan lakes and the Great Lakes. And there are some papers here that have either demonstrated the mechanism by which dry-scented can facilitate HABs, or they've shown that dry-scented mussels can selectively feed good algae and reject cyanobacteria, giving cyanobacteria yet another edge in selection pressure. And what the dry-scenteds do is they filter particulate matter out of the water column. Okay, they clear the water column, they make it clearer, which allows for better light penetration, which cyanobacteria can then utilize for growth. More light penetration equals warmer water temperatures, which cyanobacteria like. Some can selectively feed and reject the cyanobacteria. And one of the big things they do is they take particulate matter, they filter it, and they spit out dissolved nutrients, which the algae can use for immediate growth. So they're having a big impact on our lakes. This is a graph that has come out of New York State research. It's a little complicated, but what it's showing is average total phosphorus concentration in a lake and the likelihood of a shoreline harmful algal bloom. Okay, so what you can see, there's two lines. This orange line is it says no zebras. It means no zebra mussels. I don't think any of our lakes have zebras. Maybe, but so the orange line, you get an increase in the likelihood of a HAB with the more phosphorus that you put into a lake. Okay, that red arrow is about where Canandaigua is. The blue line is the likelihood of a HAB for any given level of phosphorus if you have a zebra mussel or a quagga mussel in your lake, impacting the lake. Okay, so this has come out of the HABs summits in New York State research, that in the presence of quagga or zebra mussels, you're more likely to have a harmful algal bloom than without. This past September, I was lucky enough to get on Canandaigua Lake with an underwater camera device that my colleague Lou McCaffrey made. I'm going to show you some photos. These are not entirely representative. I think I did 5 casts, but it'll give you a feel for what's in the lake. These are mostly off of Vine Valley, which is in the southern end. That's at 16 meters. Okay, that's at 30 meters. Kevin stole my thunder a little bit and showed that one. But that's a bigger picture. On the surface layer of this photo is somewhere around 10,000 individuals per square meter. Okay, and I had a nice conversation with Bruce Gilman, who took basically ponar or clamshell grab samples of the physical mussels, and there were spots where he got more than 70,000 individuals per square meter. Multiplied over the area of the lake, that's hundreds of millions of individual mussels who are, doing their thing to the lake water, filtering out, and causing problems for us. That's the side-looking view. That's the down-looking, same photo, but side-looking. And you can see, at least at that area, it's just like pavement. Okay, they're everywhere down there. That's at 40 meters, which is around 120 feet. And that's at the bottom of Deep Run, which is about 170 feet deep. They're from top to bottom in Canandaigua Lake. And that's consistent with some of the mussel surveys that we've been able to do on the Finger Lakes and that others have done on Cayuga Lake. A researcher out of Cornell found quagga mussels at 300 plus feet in Cayuga Lake as well. And so as Rebecca said and others have mentioned, there's likely not one thing that's happening now that's causing the HABs that we're seeing. It's likely a lot of different things, interannual variability in temperature patterns, runoff, but it's likely that all of these factors are kind of tipping the scales in the HABs direction in Canandaigua Lake. You'll see that I have the nutrients starred, and to come back around of these things, the only one that we really have even the hope to control is watershed or external nutrient sources. Okay, so how are we moving forward? With education and outreach, we the DEC, helped the Canandaigua Lake Association set up their monitoring program for HABs this year, and we didn't expect them to be quite as busy as they were, but I will say that they did an amazing job coordinating all those samples for the better part of the second half of the summer. Okay. And so the DEC's on-site website and the Canandaigua Lake Association, great resources for the public. Increased monitoring assessment, looking at new techniques. This is a surface map of estimated chlorophyll concentrations in September from Canandaigua Lake that the DEC has been able to develop an algorithm from satellite pictures to estimate chlorophyll concentration lake-wide. And the whole surface area of the lake can be mapped now with just flyovers from satellites. We're looking at new instrumentation to map the extent of blooms in 2 dimensions, in a lake, or 3 dimensions vertically, to see where the HABs are, their depth extent, how much of impact they're having. Through the Governor's HABs initiative, it's now expanded above and beyond the 12 priority lakes. The DEC will be doing more intensive monitoring in Canandaigua Lake next year, doing multiple sites from the north end, open water to the shoreline, for nutrients, algal indicators, toxins, to help us get a better feel for where and why the HABs are in space and in time in Canandaigua Lake. And so what's driving these HABs? We need to look at, Kevin obviously did a great job explaining the Canandaigua Lake's watershed assessment programs. Keep honing in on what are those external sources. We have to consider the form of nutrient that's being loaded to our lakes. Some forms aren't as readily available to algae as others. So looking at the dissolved forms, for example, is important. Better quantification of mussel impacts, looking at the whole lake nutrient budgets, what's coming in from where and where is it leaving, so that we can get a feel for how to manage that. Are the blooms forming near shore or open water, or some combination of both? Looking at why the toxins are distributed the way they are, why were they found at depth and not at the surface at certain times, looking at what's triggering blooms and what causes those to collapse, and of course looking at things like biocontrols. Currently, there's New York State DEC research trying to connect dry sennit or mussel density and the distribution of toxins in New York State water bodies, and evaluating citizen science techniques for doing the things, underwater video surveillance, mapping, and quantification of mussels. And Rebecca touched on, the HABs mitigation treatment, so I think in the interest of time, I'll skip over that. And so we kind of have a saying, you do what you can to control the controllables. Develop clean water plans or watershed-based approaches to improving or protecting water quality. And again, above and beyond what already is done in Canandaigua, this is a nice approach. Doing a 9-element plan, for example, would make the Lake Association and the watershed groups more eligible for more funding to fix some of the problems in the watershed. And just keep hammering, reducing nutrient inputs from the watershed, because like I said before, that's the only thing at the moment we really have a chance to control. And I think I'll step aside for now, but I think we're going to be available for questions at the end.
Thank you, Tony. Really fascinating stuff. Why don't you come on up? Okay. Our next presenter is Lloyd Wilson. Dr. Wilson has worked for the Department of Health for more than 30 years in numerous roles, focusing on understanding human health exposure to chemicals and biological contaminants in the environment and to mitigating these exposures. Since 2004, he has focused on drinking water issues and is currently working on understanding the drinking water health concerns associated with harmful algal blooms, private well contamination, the impact of climate change, and emerging chemical contaminants such as pharmaceuticals in drinking water. Dr. Wilson received his PhD in environmental health and toxicology from the State University of New York at Albany's School of Public Health and is currently an assistant professor at the School of Public Health Environmental Health and Toxicology Department. Welcome.
So you've been sitting for a while, so if anybody wants to stand just to get the blood flowing, go ahead. I won't, move around a little bit, stretch. That's good. Couple of quick things just listening to the other presentations that I think are important facts that you should understand. The thing about harmful algal blooms that's really kind of not understood at this point is a bloom on one day will not produce any toxin. We still have those concerns that Rebecca talked about, the lipopolysaccharides, kind of like a poison ivy type deal. We don't want people going into one and getting that type of reaction on their skin. But most of the discussion has been about toxins the last couple of years. And so the bloom one day may not have the toxin. You go back the next day, it's basically the same bloom, and now it's producing a toxin. So the toxin gene gets put on and off, and so that's just one of those mysteries that we need to unlock and understand. I came here because I'm currently the director of the Bureau of Water Supply Protection. Basically, I have the responsibility for all the drinking water supplies across the state. So my talk is focused on drinking water, but I'm also very active with the beach program in terms of the collaborative effort. This harmful algal bloom thing requires a mixing of people with different backgrounds in sciences and social science and government. Kevin really hit it on the head. This is going to be a collaborative effort as we move forward throughout the state in terms of a HAB program and in particular the drinking water program. So those are some key things that I wanted to stress based on their earlier presentations. Let's see if we move it. We did. We moved it twice, didn't we? Okay. So 3 years ago in the spring, May in particular, EPA came out with a health advisory for cyanobacteria toxins. And by the way, just to help with the confusion, blue-green algae, harmful algal bloom, cyanobacteria. So when I was in college, undergrad, they were known as blue-green algae. The taxonomy had them as blue-green algae. And with the development of genetics and other testing, the taxonomists refined it and recognized that they really weren't a true algae, but indeed a bacteria. So they got the name cyanobacteria. So that's why there's this mixture of names. So microcystin is the toxin that is mostly found in New York State. It is the thing that is found, if you look at DEC's data, and again, Rebecca touched on this, we talk almost on a daily basis, or communicate on a daily basis, very much in tune with each other, where we're finding HABs and so on. But microcystin is the one. And so that's the one that we have focused our efforts on, because if we're going to find a toxin, that's the one we're going to find. And EPA came out with a health advisory for bottle-fed infants and preschool children of 0.3 micrograms per liter. And the thing interesting about this is they also had a value for the adults of 1.6 micrograms per liter. And these health advisories are that. They're a health advisory. There's no regulatory arm with them. There's no, we can't cite somebody for being in violation. It is a health advisory. It is guidance. And EPA puts that out there with these emerging contaminants, and so the states are then kind of left up to the states to try to figure out how to implement. And how do you take that health advisory and put it into something pragmatic in terms of providing guidance and oversight to our public drinking water systems? So the other thing that's a little complicated by the fact that they have a value of 0.3 and a value of 1.6. So let's just take a child that's 7, all right? You know, well, a year ago, 0.3 was the number. Now he or she is 7, it's 1.6. So that right there is kind of a little thing that we have a little bit of a problem with in terms of the Department of Health. The other side of it is a 10-day health advisory. And the reason EPA did this, and I'm not slamming EPA at all, I really applaud EPA. In fact, I worked on the work group that helped come up with these numbers, working on a subgroup for EPA. And I really applaud them because at least they're out there giving some guidance, which is better than doing nothing. But they did a 10-day because the animal studies that were used to base these numbers were what they call a subchronic study. Studies typically are something they call LD50s. You give a lot of something to animals, and when half of them die, that's the LD50, lethal dose 50. So that's an acute. That's a serious problem, obviously. And then they do something that they call a chronic study, where they study the animals for over a year, giving them different doses of the toxin of concern or the contaminant of concern. In this case, the study was like a 30 or a 40 or 50 day, and I don't remember exactly, but it wasn't a full year study. It was a subchronic study. So EPA took that number, and said, well, we're going to make this a 10-day health advisory. Okay, let's go back to being pragmatic. How do you implement a 10-day health advisory? Does that mean if you're below the health advisory for 7 days and then you go above it for 1 day and then you go back above it for 3 more days, so you got 10 out of 11 days, but they weren't 10 days in a row, you get the point. There's all sorts of permutations of how to implement a 10-day health advisory. So what I want and why I'm spending a little bit of time on this is I think this is really the key message I want you to have. And if you want, we can go to questions right after this. The Department of Health has taken a very, very proactive, conservative approach. We went ahead and say, if you're going to get an exceedance above the 0.3 1 day for the most sensitive population, then we're going to take action and make recommendations not to drink the water. We're not going to have get mirrored up in whether it's 7 days, 8 days, 9 days, 10 days, 11. We're just going to be very proactive, make sure that there's a message put out there, and work with the water systems to do what we can to get that number below the 0.3. All right, so enough on that one. So just to even go further in terms of the conservative approach, went the wrong direction. I want to kind of give you another understanding of how conservative that number is. Over here is the 0.3 for 10 days. And again, we're applying it on a 1-day basis. We would not expect to see any health issues until there was a value above 300. So we've got a 1,000-fold kind of built-in margin of safety, if you want to put it that way. And that's done for a couple of reasons, because the science isn't exact. We went from animals to humans, and how we process something is a little different than how an animal does. But again, I want to really stress to you that this is a very conservative approach. I think it's the right one. It's very proactive, and that's the history behind those values. Okay. All right. So this community experienced this. I'm talking about Canandaigua as a whole, obviously the one system in particular. All right. Whoops. So I just want to kind of give you a little bit other things. Kind of go through these fast, as I think it's getting later than the organizers planned. We have been doing, we went out and got a grant from CDC 3 or 4 years ago, and have been trying to figure out what is the actual health signal in New York. And what I can tell you is it's very difficult to ascertain or to decipher what that health signal is, because most of the symptoms are stomach ache, fever, things that coincide with maybe eating bad clams over the weekend or drinking too much beer or whatever other activity people may do. And so trying to figure that out. But to the best of our ability, we have not seen any health issues associated with somebody drinking water. We have seen it with people swimming. And not swimming at our regulated facilities when following the policies of the if it's closed. We've had people sneak in after it was closed and they got sick. And that probably was related to the HAB exposure. But in terms of the actual facility, we have not seen that happen when it's being properly managed. And a relatively low number of people, but still people have been sick. Just kind of going back, this was a big event back in 2014. If you can recall, the governor of Ohio declared an emergency, brought in the National Guard. If I remember right, 400,000 people were told not to drink the water. And this really got EPA going, and that's why in the following May of 15, they came out with a health advisory. Okay. So I think a couple of things when you talk about drinking water is you got to understand the placement of the intakes. For the most part, intake placement is something that's reviewed and approved by Department of Health and when a new intake is put in there. And for traditional reasons, the intakes were put away from shore. Obviously, shore is where you get more turbidity, you get more animal activity, and so on. And I think this is a really important thing. I got to give a plug to the public water supplies. With the emerging contaminant and pharmaceuticals and the HABs, these are all things that our public water supplies have to address. But the very first thing they have to address is microbial contamination. And that's what happened in the turn of the century, I mean the 1900s, 18s to the 19s. If you go back and look at cemeteries in the 1880s and 90s, you see whole families there because of cholera and other microbial diseases. And that's really when water treatment took off and disinfection took off. And that's still, we have to really keep our focus on that and make sure that we don't slip there. But we've been adding all these other pressures onto our public water systems in terms of dealing with chemical contamination and issues now like HABs. So this complicated diagram, and I'll say it's complicated, is for one purpose only. Let's just talk about a harmful algal cell, a cyanobacteria cell. I'm a happy little cyanobacteria, and I decide to start producing toxin. Well, the toxin's within me, and I'm just floating around in the water, having a great time, doing whatever I want to do, and that toxin's inside me. Now, if I get to a filtration plant, that filter will pull me out, and with the toxin that's inside me. If I do something to destroy me, I release that toxin into the water, into a soluble form, and now a filter plant cannot remove the toxin because the toxin's no longer inside the cell, which is what the filter plant removes. And so when we work with the water system, we try to figure out, what form of the toxin's there. Is it in the cells or is it in the soluble? And one of the things that gets complicated with the zebra mussel issues is that the intakes, to help control the mussels from clogging intakes, people apply chlorine to control and reduce the mussel growth and clog mussel growth. Well, that chlorine is going to kill the cyanobacteria, release the toxin into the water. So that's going to stop the filter from being able to remove the cyanobacteria cell. Now, if we chlorinate enough, it actually destroys the toxin itself. And so there's this balance of, do we just try to chlorinate right from the start, which is what we did at Syracuse and Skinny Atlas. We upped the chlorine levels right at the intake, because they have no filter plant, right up the intake, so that the chlorine dose was as high as we could have it, so it would destroy the cells, release the toxin into the water, let the chlorine react with the toxin in the water, destroy the toxin, and by the time that water gets to the first customer, it no longer exists. And so there's this optimization of working with the water system to figure out what the best plan is for them to provide treatment. All right. So this is just what they call a contact table. This just describes if you add chlorine in the toxin and for an amount of time under certain pH and other water characteristics, how long it takes to destroy that toxin. So this is just going to what we did this last year in terms of sampling out here. You can see in terms of the finished water samples, what this really shows is that your treatment plants, except for one case, are working. And after a little bit of discussion with Rushville, we made sure that that system is working, and subsequent samples, it was non-detect. And just to show you, this is what was in the finished water. So, that's overall good news. I mean, obviously the one is not something we want to do again, and we have to work on to make sure that those circumstances don't happen. And if it does happen, we have to make sure that we have, I think there's some room for improvement. Every time you do something, you should build on and make it better. I think there were a couple things with that episode, if you want to call it that way, that circumstance that could be done better, and we're going to work on trying to do that. But overall, pretty good news in terms of your finished water. You can see here that when you talk about how many times there was a detection in your raw water, it was pretty common during this period of time. And that, again, showing the previous slide, the fact that only one time did something come through that the treatment did not work. I just wanted to go back and kind of talk about the state as a whole. And again, we're still getting the 2018 data together. This was something that I presented at the HAB summits on behalf of the Department of Health and the state. But we did a lot of sampling, and you can see the good news in terms of the finished drinking water was that we never had anything above that very conservative number of 0.3. This requires us, it doesn't mean that we're done. It just means that we have to be diligent, we have to keep on top of this, we have to keep monitoring, we have to work with the water systems to make sure that they have their operations in good order. All right, so this probably will not make me very popular with a few of you, but I just want you to, I think it's very important because we always get asked about what about a private intake. I have a private intake. I've been drinking that water for years. I, as a kid, used to drink water from the stream until one day I went 20 feet up and I found a dead beaver, no, it wasn't a beaver, a porcupine in the water, and I was drinking that water from that stream in the Catskills, 10 feet down. And all the training I went through in college, all it takes is the wrong microbe to be in your water and you've got a problem. And if you've been drinking water for 10, 20 years, congratulations, you got away with it, and you may still get away with it the rest of your life, but every time you do that, you are taking somewhat of a chance. The reason that we advocate for public water systems is they have trained operators, they have disinfection in place, they have to meet regulatory requirements to make sure that those microbes that are present do not make anybody ill. And so there we are with that. And that's just some of the stuff that we did in terms of outreach, Cayuga did in terms of outreach. It's a map that we did of the Skinny Atlas when we were doing the samples. You saw from 2017, we did 300 plus samples. I used to love September and October, but the last 3 years I haven't had a weekend off in September and October because of HABs. So I've decided I go with a different season now. So this is what I would say in terms of what we have to do. We have to work with water systems. I think we'll be reaching out to the water systems or local health departments to get a plan in place for next summer. There are, quote, plans in place already, but I think let's take a look at what happened this year and see where we can do things better. I think, I think that's where we're at. I'd just like to point out, we have two of our regional engineers here who were very instrumental, Highland and Kendall, in terms of responding. I'm in Albany, and coordinating and getting sampling and understanding what's going on at a plant is important. And I think this is another thing, besides the toxin issue, I think this is another thing why we need to work and, hopefully these initiatives on research as to why the HABs are occurring. It's not just about toxin for the water treatment plants. They have a greater demand on their filters. They have to do more backwashes. They have to use more chemicals. There's just a greater operational cost associated with the harmful algal bloom. And I think for the most part, you should be able to walk away here with confidence that people are really out there trying to protect your finished drinking water from these systems. And we had one thing go wrong here, and we got that corrected. Within 2 days, 3 days, we were able to lift because we had 2 days of sampling right in a row showing that the operation had been done such that it took care of it. And so I think you can be confident about that, but you should also recognize there is a cost to this, and then that's the actual operation of the public drinking water treatment system. So with that, I think you probably have sat long enough.
Thank you, Lloyd. And at this time, we're going to set up our panel up here. So if I could ask all the presenters to come up to the front. We're just going to take a few minutes to get set up. When you walked in, you may have been handed a note card. And in the process of this event this evening, you could have jotted down a note or two or a question. So we're going to do this 2 different ways. If you have a question that you'd like us to ask, make sure you grab one of our volunteers walking up and down the side here, hand them your note card, and we can feed the question to our presenters. Or we will also be walking around with some microphones, so grab one of us and we will get your questions answered. Thank you. Test. We're going to have to pass this back and forth.
Here, I'll start with one that has my name on it. That made it easy. How extensive is DEC reporting of HABs? Otisco is surprisingly low, only 1 week in 2018. Is hemlock and Canandaigua monitored 0 weeks in 2018? So, as I mentioned in my talk, our reporting network is kind of a patchwork network. So it is variable across lakes. Not all lakes are monitored with the same extent. Otisco actually has a similar volunteer monitoring network, a network similar to the one on Canandaigua, and they have been in place. This was the 2nd year of monitoring, And there really was just 1 week where there was a small little sample, a small little bloom that broke up pretty quickly. So I think we actually can say with moderate confidence that there are not widespread HABs on Otisco, at least in the last couple of years, for probably a variety of reasons. And then hemlock and Canandaigua are very carefully monitored by the city of Rochester. They are participating in our CSLAP program, which is generally just citizens, but in the case of hemlock and Canandaigua, it's actually the water treatment operators from the city of Rochester that are doing the monitoring for both water quality and then also for shoreline HAB accumulations. And they have seen a couple little pockets of HABs pop up. They've never seen it out in the open water, but again, they're keeping close eyes on it as a water supply.
All right, Kevin, you've got a few there.
All right, here's one that's what can we do as individuals? Well, there's a lot of things, obviously, as an individual. We have a really important organization, the Watershed Association, that you can join, where there's a lot of activism, a lot of volunteer work that can be done from that perspective to truly work at that community level. And I think they play a huge role. Then there's a lot of stuff that we've identified in the Watershed Management Plan and a lot of our educational publications as to how you can manage your own landscape in terms of if you're going to fertilize, proper fertilization rates on your lawn area, the timing of that aspect, making sure you stay right with the law, which is unless your soil test is saying you need phosphorus, do not use phosphorus-based fertilizers. Typically our soil, our phosphorus levels in the soil is more than adequate to sustain a lawn. So there's things from that perspective. You know, then it gets into a lot of the other components of how you handle your dog waste. I know it sounds mundane, but it's real. There is a huge amount of phosphorus and bacteria load that we worry about from a pet waste perspective. Managing your landscape also, if you're a large lot landowner, if you have more than an acre, it's maintaining those forested areas, maintaining wetland areas. Be willing to work with the land trust, be willing to work with the municipalities to actually potentially consider donating a portion of your land into an easement so we can build more wetlands. We can build watershed resiliency, water quality resiliency into the watershed. It's donating money, quite frankly. We need money to do some of that. We need money to help the municipalities and the land trusts purchase land, purchase easements, to do a lot of that. So it's all of the above. And volunteering, yes, absolutely. We talked about the association in the beginning, joining the association and volunteering with the association and helping to identify, adding to our network of 17 volunteers right now that are actively engaged in looking for HABs.
Lloyd, why don't you pick a question from your pile there?
I'll start off, what is being done to fix the Rushville plant? So I think when we did the testing this last fall and found that one hit, we then quickly worked with the operator to make sure that the chlorination regime was being done in an optimal manner, and that ended up proving and being the solution to the issue. We saw, we sampled every day. Part of the things that we have to work on, we had to get samples collected and sent to Wadsworth Lab in Albany the same day so that the next day we could have results. So we had, if I remember right, it was a Friday, Saturday, Sunday, or Saturday, Sunday, Monday, one of those. So by that third day, we had 2 days afterwards, and it wasn't just that we went for one sample. You know, it was one sample, the sample that triggered all of the action. The lab gave me a heads up that they thought they were seeing something. The analysis wasn't completed, so I asked the lab to take another aliquot of that sample to do it, so it basically had a duplicate of the same analysis because we didn't want to be acting on an erroneous DECs, in some places there were 2 samples, it was really the same sample analyzed twice. So we were very confident that there was something actually in that water. And then when we came back to do the follow-up sampling, after we talked with the operator and worked with the system, we went out to places in the distributions. I'm sorry. Thank you. We went out to places, if you don't, I usually drink public water, just for the record, but I'm suffering from a sore throat, so I didn't, sorry, I just don't want to, anyway. We just didn't go back to that one point. We went out to places in the distribution system. I think we went out to the school. We went out to a village or town hall, 2 schools. What else? 2 schools? In town in Middlesex. Okay, and in the entry. So we went out to many locations so that we had many data points, not just one, to make sure that we felt confident. And then we had 2 full days of getting non-detect. And at that point, we felt pretty confident that the water treatment plant was being run well. I think it was always being run well, but we just had to tweak it a little bit, I think the operator, and we got everything going. So that was that. When did DOH begin testing water? Based on what? So we have tested water systems on and off since the early 2000s. And we've had a couple of different criteria, one of which has thankfully never been triggered. We have this kind of in our way. One is if we hear reports of illness from drinking water. That's never happened. So that's been a trigger that's never happened. Another is if a water treatment plant complains that they're seeing algae in their intakes, that's a sign for us that it's time for that water system to get tested for a toxin. Another is, on a daily basis, DEC sends us email, we send them email. Our beach operators will report back that they've closed the beach. So that information comes through our line of communication, and we send that over to DEC to say, hey, beach X has been closed because of a HAB. What do you know? In the same time, through the volunteer program, they may hear of a HAB, and they'll send us a note, and right in the subject line it says, 1 public water supply, no beaches, or whatever they believe exists. We go back and double check their records. We trust DEC, but sometimes they don't have the most recent information. So we confirm what they believe in terms of the number of water supplies and the number of beaches. And then if they confirm that it's a HAB and the HAB is close, if we have a 20-mile lake and the HAB is a 2-foot puddle on the north corner, we're not going to sample the water system down on the far side. But if it's a large HAB or if it's a HAB near the intake, we will then work and coordinate sampling. So that kind of goes on how we do the testing. And I forget exactly the reason why we went here, but I believe it was based on a DEC report. So you want me to keep going, or you want to pass it?
All right, Tony, why don't you take a crack at it?
Okay. How exactly does monitoring occur? I described the process. Is it daily, weekly sampling, et cetera? So there's quite a bit of monitoring that goes on the lakes. The Finger Lakes, for example, are in the Citizen Statewide Lake Assessment Program. The open water of those lakes are sampled biweekly, June through September. And during that process, the volunteers do user perception and harmful algal bloom surveys, field notes. They collect water samples for nutrients, algal indicators, and toxins at near surface and somewhat deeper depths. So there's that. Rebecca mentioned the state's in-house program, the Lake Classification Inventory Program. That is, remind me, monthly? Okay. At least monthly, sometimes once a season, where they get sampled for the same sorts of indicators. The shoreline surveillance networks that run on some of the Finger Lakes like Canandaigua and Seneca, they are usually weekly surveillance programs where they monitor specified zones. They look for the presence or absence of harmful algal blooms. Sampling is triggered if they see an event. I know some folks are looking a bit more frequently than weekly, but I think that answers that question. Did someone have something more specific in mind with regards to monitoring? The weekly HAB surveillance teams, right, so they will inspect their shoreline weekly.
I'm going to have her repeat her question.
Oh, okay, so it was
I just questioned, I'm from Cuca Lake, and we're trying to start a similar program to your shoreline monitoring. So I was trying to find out exactly how you do it, and one of my questions is, well, this was my question, was how do you do it? So when the volunteers who are monitoring the shorelines in their zones, when they see a HAB, do they just go ahead and take a sample and then, I guess, take a sample and send it up to Finger Lakes Institute and then, et cetera, it goes on from there?
right, so they'll surveil weekly, right, so if they don't see a HAB, they note that, because that's important information also. If they see a sample, or see a HAB, they can photograph and send it along for verification by the DEC or local partners, and then they can take a sample if warranted, and then send that directly to the onshore screener or the DEC's contract lab, and in the case of Seneca and Canandaigua, FLI is serving as that screener.
And so Lisa at FLI said that Rebecca and the DEC trained these people so that they know, the volunteers, so that they know how to recognize the HABs and the proper way for sampling and all that. Is that correct?
Yeah.
Oh,
Yeah. Yep, we have training programs for new groups and retraining for volunteers that are interested in getting a refresher. But those trainings take place in a few different locations and times, including for the Finger Lakes.
We have a question back here from Wade Sarkis.
Thanks for being here. You mentioned one Finger Lake did not have, yeah, I wrote it down, you already read it. One Finger Lake did not have HABs this summer. Do we know anything about that? Which lake was it? Do we know anything about their mussel population and density?
So we're 90% sure it was Canandaigua. It was either Canandaigua or Hemlock, one of the two Rochester supply lakes, and whichever, I'm pretty sure it was Canandaigua, and Hemlock also only had a very small, isolated, very short-lived bloom for like just in one day. And I think you were getting at, maybe we can figure out, you know, why those lakes have blooms and not others, but unfortunately it's not as cut and dry as that, and while the Finger Lakes have a lot in common with each other, they actually have a lot of differences as well, with Honeoye being quite eutrophic, Canisius and Otisco having a lot of other water clarity issues, and Owasco, which has been our, you know, hardline HAB lake for several years, barely bloomed this year, while the blooms in Seneca, Cayuga, and Canandaigua were substantially longer and more widespread than previous years. So, you know, while the Finger Lakes are kind of a nice collection of lakes that are geographically similar, they seem to have some different properties going on. And I think your question also got at, you know, whether the zebra or quagga mussel populations are different among the lakes, and if we can use that as an indicator. And unfortunately, we don't have a good data set of where are the mussels, where are each of the two different species, do they overlap, what has been the trend over time of the expansion of these invasions, and that would be really helpful data to have right now to look at that question. So we're starting to collect that information with the microview photos that Tony and Kevin showed, and we'll see if there's trends in that, but we don't have that answer right yet.
All right, next question. It's a long one, so I'm going to try to abridge it. How can we ever have clean water when Naples empties their septic tanks into the lake, and the 700 to 800 cottages have septic tanks on the shore and the West River from Gorham and Rushville? So there's a lot there. We have George Barton in the back. George, raise your hand. George is our full-time watershed inspector who works for the Soil and Water Conservation District and is contracted out to the 5 purveyors forming the Watershed Commission. So we have a full-time inspector that's looking at all these systems, has regulatory authority to implement regulations and to work with the local health departments, the municipalities, to make sure we get enforcement when it's needed. We also have worked with those local municipalities, the shoreline municipalities especially, where we have, and we'll have all 5 of the 6, we'll have, or 4 of the 5, the city's all sewered. 4 of the 5 shoreline municipalities make up about 34 of the 36 miles of shoreline. We'll have adopted the new on-site wastewater treatment law that is pretty darn aggressive, quite honestly. Balanced but aggressive, where we require 5-year inspections of systems within 200 feet of the lake. We require substandard systems to be upgraded, not failing systems, but substandard systems to be upgraded at the time of property detransfer. If a failed system is found, and we have expanded the definition of failure and made it more comprehensive, those systems must be upgraded immediately. So this is something that is vastly improved. Village of Naples, they also have, George works full-time in the Village of Naples at times and has done a lot of work over the years to make sure that those systems have been upgraded. He never sometimes is the best friend down there or elsewhere. We call it kind of good cop, bad cop to a certain extent, but he has a very difficult job and does a tremendous job of making sure that these systems are being well managed. So we have a lot of that to our favor and to our advantage. And then the Village of Rushville does have a sewage treatment plant. Gorham's does not go into Canandaigua Lake. Village of Rushville does, and Bristol Harbor also does. Village of Rushville's plant is actually being upgraded. It actually works 10 miles through the West River system and then through the High Tor Wildlife Management Area wetland system before it enters the south end of the lake. So there's a lot of treatment going on at the plant and then biologically through that system. Then Bristol Harbor, during their busiest time frame, they use their wastewater, their treated wastewater on the golf course. So it's tertiary treatment and it goes out onto the golf course for use as recycled water out there as well. So hopefully that gives you some answer as to the issues of on-site wastewater systems and wastewater systems. I did have another one. What is that white foam on the lake? That's right. What is that stuff, right? We've been seeing it since September of 2001. On and off, some years more so than others. Dr. Greg Boyer, Bruce Gilman, John Hassett from SUNY SF have all been involved in researching what is causing this foam. We know it's organic matter that's breaking down. It creates a natural surfactant which reduces the surface tension of water. Our lake, Skinny Atlas Lake, Owasco Lake has been seeing foam on each of our lakes. Where maybe the perfect scenario where we have this long lake that creates this cell where you get this internal wave action that brings that organic matter up to the surface, reduces the surface tension of the water, and it creates these long, it's called Langmuir circulation, these long streaks of foam based on all those aspects. I mean, we don't have the direct, perfect scientific evidence that backs this up, but 15, 17, and 2018, we all started seeing, the foam really get much more about a week to 10 days after the bloom started occurring on the lake. So you're potentially getting that first round of algae starting to die off, releasing organic matter into the water column. You also have at that time of frame a lot of the macrophytes also breaking down as well, releasing organic matter into the water column. So all of that in combination with the way our lake is set up in that north-south orientation creates the perfect scenario for foam to occur.
So I think these are the most difficult ones, so I'm going to go for them. Would you suggest a home filter system? Sorry. Yeah. Would you suggest a home filter system such as reverse osmosis to feel even more comfortable with drinking water? I'm not sure of the total context of this. Is this reverse osmosis on top of a public water system, or is this related to a private intake? If it's for a private intake, I'll go back to what I said before. The thing about a public water system is that they have trained operators, they have routine maintenance, and they have routine measurements to make sure that performance of the treatment system is working. Typically, home
I'm not trying to be rude, but we don't have the option of public water. Many of us are on the lake, so we take the water directly from the lake, and that's it. So,
Yeah.
we,
So, understand, and
Okay.
I'm not trying to be mean, believe me. I would love to be able to say, do this, and you'd be all set. But I can't do that because unless you do all those things that I just talked about, you have somebody who knows what they're doing, they have a properly designed system, and you do measurement to see that it's performing well, you cannot be assured. I mean, part of the reason I think a lot of you are here is because we had an upset at one of the public water systems. That does do all those things. And then we had to do a lot to get confidence back that system is working. And so you have that same issue with your private. Now, having said that, certainly reverse osmosis is a good system. I would seriously talk, you look on our website, you'll see guidance for a private intake homeowner. I would talk to a water professional. A UV light is a good disinfecting type of mechanism. So there are things that can be done, and then I would go in that route. But I, as the state drinking water administrator, can't say that your water's okay because I'm not going to come test your private intake. There's 2 million, not 2 million, excuse me. There's somewhere between 800,000 and 1 million private wells and intakes in the state. And we have 9,000 regulated public water supplies. Those are the ones that I have to put my efforts into. So one of the things that we really worked hard on, and Rebecca referenced this, is that we recognized there was a lab capacity issue, and so we got our environmental laboratory approval program to certify methodology and labs so that when somebody wants to test for microcystin, they can and get results they have some confidence in because it's being done by a proven laboratory. The problem with testing is it's always a point in time. And so with HABs in particular, and many of you probably noticed this, if the wind blows east to west, the HAB is over on the west shore. If it reverses, the HAB's over on the other shore. And so it is a dynamic situation, and it requires constant maintenance. I have a private well, and I have to be honest, I probably don't maintain it as well as I should because other things like kids and everything else gets in the way, and I don't go down every day and take a look at it, but I should. I do test it on an annual basis, which is probably more than most people. So that's what I would say. I talk to a professional, but UV is something I would consider. You could get a chlorination system there to help with the disinfectant and a reverse osmosis. Now you have, when it comes to a private home, whether it's a well or an intake, you have what they call a point of entry, which is something that is, as the water comes into the house, and therefore all the water served throughout that house, whether it be the showers, the upstairs bathroom, or wherever, is all seeing treatment. Those are bigger systems and cost more. Then they also have point of use, something, you can go to the Home Depot or Walmart or wherever and get something to screw in. And a reverse osmosis also can be done in both. Reverse osmosis takes a fair amount of energy. There's a lot of wastewater, so there is a maintenance issue with it. So it's a tough situation.
thank you.
You're welcome. I knew that was going to be a hard one. There was one about persistence, and some other people may want to talk about it. In general, there's what they call a biological half-life, or the half-life, the environmental half-life. So if you put a chemical in the environment, how long does it take for half of it to be gone? Whether UV light from the sun destroys it, something else acts on it. And in general, microcystin is thought to have a half-life of 3 days, something like that. Now, microcystin in the deeper water where it's colder may have a longer half-life than the microcystin on the shoreline. And I think this is one thing, not always, but when you see the DEC data and see high levels of toxin, most often they're affiliated with a shoreline bloom where, just based on aesthetics, you wouldn't want to go into that water. Those waters typically are the ones where the most biological activity is going on, and that's typically where those really high levels are found. And that's why we get concerned about dogs that may be going into the water. They come out, they lick their fur, And that concentrate, it's basically concentrating that toxin for them, and dogs can have a problem with that. So in terms of dispersing, you know, the half-life, somewhere, let's say, around 3 days in general, but temperature and other things make a difference.
I'll just briefly tack on to that. What we found at the summits that we held, particularly the one focused on the Finger Lakes that are more similar to Canandaigua, is that this is not an area that's well studied by researchers. What happens to toxins in deep, cold, oligotrophic lakes? We are seeing that the shoreline blooms have really high numbers, as Lloyd referenced. So that toxin does have to go somewhere to flush out of the system, and that's why those raw water intake detections may be occurring. It's just there's a lot of toxin in the water, and it's got to slowly break down.
I have a couple questions about the control of invasive mussels. I think I'll lump them into maybe one response. So there aren't any great treatment options for zebra quagga mussels once they're in the lake. There was a nice review in the Journal of Lake and Reservoir Management this past year where a lake in Minnesota called Christmas Lake, they had an infestation, and I'm using air quotes because it was a cute little infestation of about 5,000 individuals total near a public boat launch, as opposed to the probably billion that Canandaigua has. They tried 3 different chemical treatments at a cost of around $12 per mussel total over the course of a year, and they basically threw up their hands and gave up because it didn't work. It was a small little containment area. They curtained it off. They deployed their chemicals, 3 different types, and the next season they found live mussels outside of the containment area. Either they were able to reproduce and send their larvae, called veligers, around the curtains, or zebra and quagga mussels are clever little things. They can hitch rides on native mussels and clams, or they have a little foot. They can walk themselves right out of any sort of negative chemical treatment area. I think I had a slide up there about biocontrols. I think I hopefully had a question mark after it. It's an area of pretty new research. Zebras and quaggas are invasive species from Eastern Europe. There's a bit of research going on in that area trying to find native viruses and bacteria that may be usable as controls, but as far as I know, that is years off at this point. There are some native and invasive fish species, for example, that will eat quagga or zebra mussels, but you're kind of limited to whether they're in your lake already and the physical space that the fish normally live, and then having contact with mussels. So right now, there aren't any great controls for zebra mussels.
All right, we've got a couple questions in the back here.
Since the Rushville plant was the only plant that's sourcing Canandaigua water to have the toxins in the finished water, what is being done to prevent the Rushville plant from having that problem in the future?
So I think a couple of things, and I can go kind of back through Owasco and Auburn and Skinny Atlas, and I think the main thing is to get everybody on the same page, to recognize that there is the potential for that to happen. Obviously, the potential here was demonstrated, that we have a good monitoring plan in place, we have a good response plan in place, and that we make sure that the processes in place for that treatment system are operating at 100%. So it's a matter of us working with the operator and our local health department and our regional staff to make sure that when we come for next year that we have a monitoring plan in place. What we did at those other communities is we set up some sort of baseline starting, say, maybe in May, maybe once every 2 weeks. You know, we don't expect a bloom at that point. And then maybe at the first sign of a bloom, go to something like a weekly. And then back to that criteria that I talked about before, that if the treatment plant notices change in turbidity, actual algae in the have an increase in their filter changes, that we need to do a little more frequent monitoring, and make sure that they keep their chlorine residual at a good constant level throughout the whole distribution system. So I think, again, we can see that it can work, and it did work, and we just have to make sure everybody's on board, and as staff change and so on, you need to have plans because people change, but the plant will still be there. So I think that's how we're going to approach this.
Okay, in the interest of time, we'll probably take one or two more questions. So Senator Helming?
Thank you so much, and thanks for being here. This was a great presentation. So to kind of piggyback on the question that was just asked, I'm curious, does the New York State Department of Health have a list of water treatment plants that aren't currently outfitted with the right equipment to filter out the toxins? And if so, are those water treatment plants on a priority list for funding? And then I know back in 2017, New York State passed in the budget $2.5 billion in the Clean Water Infrastructure Act. Is that any of that funding available, whether it's for upgrading treatment plants, water treatment plants, sewer treatment plants, whether it's for land acquisition to create buffer zones, whether it's for septic system upgrades? Where is all that money, and how do we access it? And when we talk about small municipalities, villages, towns, et cetera, you know, that they're going to have to make more investments, I'm sure every single community would like to make those investments, but they may not have those resources. And what can New York State do to help them? They're constrained also by the 2% tax cap. What can we do to help them out with that? How can we get them access to this grant funding and move that grant funding out in an expeditious way?
We probably could spend a day and a half talking about all the questions you asked, but let's make sure we technically are right. Filtering is a process where you remove something by its physical size and shape. And chlorine does not work by filtering, it works by destroying the toxin. So I just want to make sure that we have that. And all of our surface water supplies have to disinfect. They have to apply something like chlorine. It may not be chlorine every time, it may be something else, but they have a process to disinfect. So right up front, they have a way to deal with something like microcystin. So this year, besides all the other activities that I briefly touched upon, there was another activity that we did this year, which was under the EPA UCMR, which is the Unregulated Contaminant Monitoring Rule. They are testing public water supplies throughout New York State for the harmful algal bloom toxins. The problem was that program doesn't give the results back until about a month, month and a half, maybe even up to 3 or 4 months after they do the sampling. And we felt that that had the potential of being problematic, because if they found something, by the time they got the results out, it was 3 months later. So every single water supply that the EPA, and I think it was 45, don't quote me on the number, but it was a large number of water systems that EPA was testing this year, we also tested. So where I'm going with this is, between working with DEC for several years, it's not like we just started this last year, we have a pretty good sense of where harmful algal blooms will occur. Obviously, Skinny Atlas 2 years ago surprised us. But if you look back, probably is related to a very strong microburst that happened in June that washed a lot of the ungrown farm fields and lawns into the lake, giving it a significant nutrient dose in June. And so there was probably a very specific reason why that bloom started, and we'll see what happens long term. But where I'm going with this is that we have a pretty good idea. We've been monitoring those supplies on and off. You saw the list up there where we had, I don't know, it was 10 to 15 that we tested over last year, multiple times, many of them. We did that again this year. Whenever DEC gives us notification of a bloom, we go back to our records to see if there's any public water supplies there. We went and looked at all the UCMR ones. And so we're continuing to identify areas that may be problematic and talk to the water systems and do testing to see what issues are there. I think you'll see us doing even more this coming year. In terms of all the funding sides, Mike Montisco, who works for me, I would want to bring him in to talk about all the different funding possibilities. They work in conjunction with the Environmental Facilities Corporation in terms of the Water Infrastructure Improvement Act and the monies that came out of that $2.5 billion, and also the DWSRF. But that's an ongoing discussion between the local health department and our central office that helps coordinate how those grants are distributed. Just to give you a little bit of a background, it's very important. I have 50 people in Albany that oversee the drinking water program for the state. 9,000 public water supplies that I talked about. The large part of our program is getting guidance out and working with local health departments who provide typically the direct oversight of the water system. It's not us at Albany. It's hard for me to provide direct oversight when I'm 5 hours away. But I work through the local health department. In those cases where there is not what they call a full-service health department, some of our health departments on the county level do not have an environmental health program. For those counties that do not have an environmental health program, we have state staff such as Kendall and Highland that fill that role for them, and they're located out here in the western region. We work through them, and they provide the direct oversight. So why I'm saying this is that Highland and Kendall and county personnel that work directly with water systems will tell the water system about, these are the things that you need to be doing to make your water system run properly. You need to report according to the regs. Every month there's a monthly operational report on what they've done. And they obviously will share information about what funding opportunities are out there and encourage water systems as appropriate to take part in it. But it does come back to the water system as to what they want to do.
I'll briefly get to the other half of your question about grant funding. The other huge amounts of money available are through the overarching Environmental Protection Fund, and that money is parsed out to a lot of different competitive grant processes, some overseen by DEC, some overseen by Department of Agriculture and Markets, and most of them involve the Grants Gateway, which if you go to that website, has a listing of all the open grant processes. There is specific watershed riparian land acquisition programs. There's tributary planting trees for tribs, where you can protect tributaries through that manner. And then the Water Quality Improvement Program, WQIP, is DEC's main watershed protection. That round for this year was closed in July, and the applications are being reviewed. The announcements are going to be made very soon, I believe, and all of that comes back to, similar to what Lloyd was just saying, that New York is a home rule state. So actions taken that support the local community need to be driven by the local community. So the state is not going to just give money out if there's not evidence that the local community is going to invest it, monitor it, work long-term to protect the investment, occasionally come to the table with matching dollars. So it really is, that's why these grants are so carefully reviewed, and there's a lot of different aspects of applying for the grant that need to be met in order to receive the funding, but the funding is there, and the grant opportunities will continue to become available. So the Division of Water has a newsletter called Making Waves that comes out once a week, and that often has announcements for when those types of grant opportunities are open. And municipalities, lake associations, other entities like that, soil and water conservation districts are all eligible and the main groups that will be applying to those types of grants.
Kevin, do you want to touch on that?
A lot of the projects that we showed tonight and some of the monitoring programs are grant funded through a lot of those entities. One of the things it does require is local match. Our municipalities have been very good at providing some of that local match. The association, through your donations and hopefully enhanced donations, will definitely help with that local match as well. Soil and Water has been a huge resource over the years from the ag community perspective on bringing in grant dollars to do work on a lot of the ag programs as well. You know, from a purveyor perspective, we're going to be getting the 5 municipal purveyors and Bristol Harbor together next week, the chief plant operators, to talk about what did we learn from 2018. We're going to have DOH there as well. We're going to talk about what worked, what may not have worked as well, share resources, share information in terms of when they're seeing higher turbidity levels, temperature fluctuations, which may bring their intake pipes into the warm surface waters, which is more susceptible to the microcystin aspect. So we're going to learn from each other. We're going to talk about what we can do from a lake research perspective to help those municipalities better understand and be ready for these issues, but also talk about from the treatment perspective. I usually tell folks my job ends at the intake pipes. That's what George and I usually tell folks. But really with this is it's all hands on deck, and it's how can we get these local municipalities tapped into, all right, here are the grant opportunities that Senator Helming and others have been instrumental in bringing forward, and getting them cued in with the right aspects, getting them cued in with engineering firms to help do the design aspect for any of the treatment plant upgrades, possible cross connections. So if one plant's down for whatever reason, we can get water to that municipality through municipal connections. So there's a lot of that that's going on also, and we're working with the state on making sure we're complementing a lot of the research that we're going to be doing that's going to work with what they're doing as well. So a lot of these things are happening and will continue to happen over the winter months.
So there were a lot of questions that we didn't get to tonight, but I think what we'll do is we're going to tally them up and get some responses from our presenters here and feature them in an upcoming newsletter, and check on the CLWA website for some responses to the questions that we didn't get to tonight. But I think most of our presenters can hang out for a few more minutes, so if you have questions, please feel free to filter on down here and don't bombard them, but you know, maybe pull them aside and ask your question. And I would like to thank you guys all for taking the time and traveling from Albany and Syracuse to get here. Thank you.